Hi guys, welcome to Conceptual Learning Classes. I'm Jen. We all know for centuries the human spirit has been driven by a quest to understand the universe. From the earliest observers of the night sky to visionary philosophers, the mystery of the cosmos continues to captivate us. Let's set forth in this cosmic journey together. Outer space, often simply called space, is the vast expanse beyond Earth's atmosphere, stretching between celestial bodies. It's a near-perfect vacuum filled with extremely low particle density made up mostly of hydrogen and helium plasma, along with electromagnetic radiation, cosmic rays, magnetic fields, and tiny dust particles surrounding planets, stars, and galaxies. But there is much more to space than meets the eye. In fact, around 27% of the universe is literally made of dark matter, an invisible substance that does not emit light but acts as a glue holding galaxies together. Even more mysterious is dark energy, which makes up most of the universe and is thought to drive its accelerated expansion. The quest to understand this unknown really, literally rocket science, is what we call space exploration. Also known as space research or cosmic exploration, is a systematic and organized effort focused on studying outer space through advanced technologies. It covers a broad range of activities from building and launching satellites to conducting scientific research in fields like astronomy, astrophysics, and planetary sciences. Ultimate goal to expand our knowledge of the universe and create technologies that benefit life here on Earth. Space research involves several key components. Number 1. Scientific research, studying celestial objects, cosmic phenomena, and processes through astronomy, astrophysics, and planetary science. Number 2. Space technology development, designing, building, and launching satellites, spacecraft, and rockets, scientific exploration. Number 3. Space missions, studying the retrieve and the modern missions to explore outer space, gather data, and run experiments. Number 4. Space applications, using space-based technologies for practical purposes, communication, navigation, weather forecasting, and Earth observation. Number 5. International cooperation. Countries often collaborate, sharing knowledge and resources for joint space programs. Agencies like NASA, ISro, and USA lead many of these efforts. One of the best examples of global collaboration is the International Space Station, launched in 1998. It's governed by a complex set of legal, political, and financial agreements among 15 nations covering ownership, key operations, and resupply missions. The ISS is a symbol of peaceful cooperation in space exploration. Some prominent space programs include NASA's Human Research Program, focused on understanding and solving the challenges of human spaceflight, especially for long missions like trip to Mars. ISRO's Space Program, India's efforts in advancing satellite technologies, communication system, remote sensing, and scientific research. Chandrayaan missions, India's lunar missions with Chandrayaan 1 and Chandrayaan 3 focusing on orbiting, landing, and conducting scientific studies on the moon. Pioneers in human spaceflight have also left their mark. Yuri Gagarin, the first human to orbit Earth in 1961. Alan Shepard, the first American space also in 1961. Neil Armstrong and Buzz Aldrin, the first humans to walk on the moon during Apollo 11 in 1969. Kalpana Chawla, the first Indian American astronaut and India's first woman in space. Valentina Tereshkova, the first woman in space in 1963. Peggy Whitson, the first female commander of the International Space Station. Space exploration takes many forms. Number 1. Manned missions, human-operated spacecraft with trained astronauts. Number 2. Robotic missions, unscrew spacecraft using robotics and AI for exploration. Number 3. Interplanetary exploration, missions exploring planets and bodies within our solar system. Number 4. Flyby missions, spacecraft passing close to celestial objects without entering orbit or landing like the Voyager of New Horizons mission. Number 5. Orbiter missions, spacecraft that orbit planets or other bodies like the Hubble Space Telescope or the International Space Station. Number 6. Observatory missions. Space telescopes and observatories positioned beyond Earth's atmosphere to capture clear views of distant cosmic objects. But alongside the benefits, there are significant challenges. Radiation risks. Space exposes humans to high radiation levels that may cause serious health issues. High costs. Space exploration demands massive financial resources, which some argue could be directed toward more immediate issues on Earth. Astronaut safety. Missions carry risks including isolation, radiation exposure, and life-threatening situations. Environmental impact. Rocket launches release pollutants that affect Earth's atmosphere. In essence, space research is crucial for advancing our understanding of the universe, developing new technologies, and solving problems here on Earth. Now that you have explored the wonders of space research, I hope this journey has been both informative and inspiring. Our adventure doesn't end here. There's always more to discover. Until then, goodbye and keep exploring.
Question time.
Could you tell me about the space research program that commenced on June 25, 2025?
Write your responses in the comment section and do not forget to like, share, subscribe and ring the bell icon. Thank you.